example 8, I'm going to show you how to use substitution when dealing with definite integrals. So when we solve definite integrals, we talked a little bit about u sub and kind of how it works, but now I'm going to show you with more complicated functions a couple other little techniques we use. So I'm going to put a little trick down, and this is my trick to u sub. And my trick is to think what you can take the derivative of. So for example, in this integral from 0 to pi over 3 of tangent of x times secant squared of x dx, I know that there's a definite derivative and antiderivative relationship, but we need to think which one's which. Well, I know that the derivative of tangent is secant squared. So I'm going to let u equal tangent of x. And if you take the derivative of tangent, you're going to get that du is equal to secant squared of x dx. Now what we need to talk about is our limits of integration. So if x is equal to 0, which is from our integral from 0 to pi over 3 of something, then u is equal to tangent of 0. Right here what we're doing is we're plugging the x value in for tangent of x. So u is going to be equal to 0. So this is going to turn into the integral with our lower limit being 0. Then if x is equal to pi over 3, then u is equal to tangent of pi over 3. So then tangent of pi over 3 is radical 3. So then you get that the pi over 3 limit turns into radical 3. So I'm going to show you two ways to solve this. The first way is going to be by changing the limits, and the second way is going to be without changing limits. So this becomes the integral from 0 to pi over 3 of tangent of x secant squared of x dx. And now when we do our u sub, we're going to get that this is the integral from 0 to radical 3 of u du. Remember that all of this became our u sub. So now we're going to integrate, and we get that this is equal to u squared over 2 from 0 to radical 3. And this is going to become radical 3 squared over 2 minus 0 squared over 2, which is radical 3 over 2. Oops. Which is just 3 over 2, not radical 3. So that's way 1. Now let's talk about way 2. And way 2, this is how to keep your limits. So we have the integral from 0 to pi over 3 of tangent of x secant squared of x dx. And this becomes the integral from 0 to pi over 3 of u du because of our u sub. Keep in mind that we're not going to be using these limits yet. So this is u squared over 2 from 0 to pi over 3. Now, we're not going to plug these limits in yet. Not yet. Because these are in terms of x. And this is the letter u. So what we have to do first is we have to put our u sub back, like we would do with indefinite integrals. So then this is going to be tangent squared of x over 2 from 0 to pi over 3. So this becomes tangent squared of pi over 3 over 2 minus tangent squared of 0 over 2. And tangent squared of pi over 3 is going to be radical 3 squared over 2 minus 0 squared over 2, and you get 3 halves as well. So the way it works is you can either solve it like an indefinite integral and then just plug in your limits, or you can just change your limits of integration. So what I want you to do on your own now is try to evaluate this definite integral one way or the other. It's up to you. Okay, here we go. All right, so way one, I'm going to change my limits. So this would be the first method I'll show you. So we start with the integral from 0 to 2 of 2r divided by the square root of 4 minus r squared dr. And what I like to do before I even get started on any of this, I'm going to identify my u sub, and then I'm going to change my limits. So what I'm going to do here is I'm going to let u equal 4 minus r squared. So du is going to be equal to negative 2r dr. Notice that I do have that right here in the problem, except it's positive. So what I need to do is I need to divide by the negative 1. So I get negative du is equal to 2r dr. And then I'm going to show you what my limits would be. So if r is equal to 0, which is my lower limit, then I get that u is equal to 4 minus 0 squared, which is 4. And if r is equal to 2, the upper limit, then u is equal to 4 minus 2 squared, which becomes 0. So now we're going to go ahead and use all that information to do our u sub. And I'm going to rewrite my integral as 4 to 0 of negative 1 divided by the square root of u du. So what happened here is the 2r dr turned into negative du, so negative 1 times du, and the 4 minus r squared became square root of u. So I'm going to bring that negative out, and I get 4 to 0 of 1. I'm going to rewrite the 1 over square root of u as u to the negative 1/2 du. And then I'm going to go ahead and change my limits to 0 to 4 by multiplying this thing by a negative. Now when you multiply it by a negative and a negative make a positive. So now we're going to go ahead and integrate. And we're going to get u to the 1/2 divided by 1/2 from 0 to 4. So I get 2 times the square root of u from 0 to 4, which is going to give me 2 times the square root of 4 minus the square root of 0, which is 2 times 2. So my answer is 4. Now we're going to do the same thing in a different way. So this is way 2, and this is without changing limits. So I get the integral from 0 to 2 of 2r divided by the square root of 4 minus r squared dr. I'm going to do my u sub, and I'm going to get the integral from 0 to 2, 1 over, negative 1 over the square root of u du. So I get the integral negative 0 to 2 of u to the negative 1/2 du. And this is going to give me negative 2u to the 1/2 from 0 to 2. So this is negative 2 times 4 minus r squared from 0 to 2. And it's going to give me negative 2, 4 minus 2 squared minus the square root of 4 minus 0 squared, which is negative 2 times 0 minus 4, or 0 minus 2, which is going to give me 4. So you do get the same answer both ways. I think that way 1 is a little easier, as long as you remember to change your limits. If you like to work with just indefinite integrals, way 2 might be a little easier.